This is LeetCode challenge number 70. It's called climbing stairs. We have to imagine that we are climbing a staircase. It takes n steps to reach the top. Each time we can either climb one step or two steps at a time. In how many distinct ways can we climb to the top? There is an underlying pattern in this challenge. So I'm just going to drag something that I have here. So we have n steps and here n equals 0. So how many ways can we reach the top if we have 0 stairs? There is only one way, which is basically do nothing. If the number of stairs is 1, then we have only one way. It means just hop on it and that's it. You're at the top. If we have 2 stairs, n equals 2, then we can either climb to the top by stepping one by one, or we can simply jump from the ground to the top and skip the 2 steps to reach the top directly. Remember that here they say we can climb 1 or 2 steps at a time. So if n equals 3, we can do 1 step at a time, or we can put our foot on the first step and then skip 2 steps and reach the top, or we can simply hop 2 steps from the ground and then make one last step to reach the top. If there are 4 steps, n equals 4, then there are 5 ways, which are the ones that you see here. And if n equals 5, we have 5 stairs, then these here are the distinct ways in which we can reach the top. Notice the pattern here. When n equals 2, there are 2 ways, that is the equivalence of the sum of the 2 previous numbers, when n equals 0 and n equals 1. When n equals 3, there are 3 ways, which is the sum of n equals 2, 2 ways, plus n equals 1, 1 way. When n equals 4, there are 5 ways, which is the equivalence of the sum for n equals 3, which is 3 ways, plus 2 ways. And when n equals 5, there are 8 ways, which is the equivalence of the sum for n equals 4, 5 ways, plus n equals 3, 3 ways. What you see here is actually the Fibonacci sequence of numbers. If we want to derive a formula to calculate the number of distinct ways in which we can reach the top, then we can pass n to a function and it will be the equivalence of the number of distinct ways for n minus 2 plus the number of distinct ways for n minus 1. If you've forgotten about the Fibonacci sequence, it looks like this. We have 0, 1, 1, then 2, 3, 5, 8. Notice here, 1, 1, 2, 3, 5, 8 is the same thing as what we have here. 2 ways, 3 ways, 5 ways, and then 8 ways. The difference here is that they are starting at 0. In our case, when n equals 0, we have 1. So we begin our sequence from 1. And that is fine because here they say the sequence commonly starts from 0 and 1, although some people start the sequence from 1 and sometimes 1 and 2, right? So it's not really fixed. You can start at 0 or you can start at 1. For this challenge, we have to start at 1. We don't need to use recursion to solve this challenge, otherwise computationally, it's going to be a very large problem. The first thing that we have to check is if we have less than 2 steps, then we have to return number 1. I think for one of the test cases, they give you a negative value just to test your logic. So in this case, if we have a negative value, it's going to be 1, which is fine. Otherwise, we can create an integer, which is what we're going to return. This climb variable is to count the distinct ways in which we can reach the top. Now I need to get an array because I'm using a dynamic programming approach. We are solving this challenge here using dynamic programming, where we take a sequence of decisions at every step and we return eventually the answer, which is the accurate one. And we also try to minimize computation by caching the solutions to the sub-problems. So here they say in the constraints, the number n is between 1 and 45. So I need an array of size 46. Like I say here, 45 plus 1 for the constraints. Here, the indices or the index at every position corresponds to the steps. For example, n equals 0 would be index 0, n equals 5, that is index 5, and so on. So we go from 0 to 45, that is why I have size 46 here. Now first I need to set when n equals 0 or n equals 1, the number of distinct ways is 1. From there, I can begin a loop from index 2 all the way to n. And at every iteration, I just need to add up the 2 previous values and store them at index I in my array called answer. So this way, I don't need to call multiple functions. I simply start by adding 1 plus 1, that is 2. Then I will do 2 plus 1, that will be 3. Then 3 plus 2 will be 5, and so on. And I'm simply getting the values from my array here. And at every iteration, I need to make sure that I store back the latest calculation, the latest sum, inside of my variable called climb. When I'm done, I just need to return the variable. So that's it using dynamic programming for the coding challenge called climbing stairs. Let's run the sample test case. We've passed it without any issue. And now we can simply submit it and it should be fast enough. So we had 5 milliseconds, memory usage was relatively low. There are other ways in which we can solve this challenge without even using an array, because the Fibonacci sequence of numbers can actually be solved without using a data structure like an array or a vector or something like that. You can just solve it in constant auxiliary space. So in the next video about the Fibonacci sequence of numbers, I'm going to cover the optimized way of solving it. For now, this is it. We explored dynamic programming for the first time in this LeetCode series. If you like my solution and you want more coding challenges and coding interview questions, please subscribe to my channel and I'll catch you next time.